The first example given in the book, a block of wood of mass 50 kilograms, okay, mass 50, is dragged across a rough horizontal surface by means of a string, which makes an angle where tan A is equal to 3/4. Jot it down straight away. So just do your little triangle to avoid mistakes. Opposite, adjacent, hypotenuse. So we can see a sine is the opposite one. Sine A is equal to 3/5. 3/5, and cos A is equal to 4/5. We're also told the coefficient of friction mu is equal to 1/4, and the tension in the string is 150 newtons. So we're asked to show the forces acting on the block. So our rough horizontal ground, we don't have to draw a rough line, it can still be smooth. We have our block, it's getting dragged by a string. We have a force going up this way, and we have a force going across this way. Our x and y, if you want to call them, they relate to our angle. Opposite the angle, we have the sine component, dependent on the force that's going along the string, which in this case is 150. So 150 sine A and 150 cos A. We'll put the answers to those in. Do that in a sec. We have the normal reaction of the ground. We have the weight going down, which we know is equal to its mass times gravity. So this force going down is 50g, and 50 by 9.8 is 490 newtons going down that way, and this way we have mu or. So 150 sine A is 90 newtons, 150 divided by 5, 30 times 3, and 150 cos A is 4/30, which is 120 newtons. So these are all the forces acting on the block. Part 2, the magnitude of the normal reaction at the ground. So this or, so what's going on in this direction? We have or going up, we have this one here going up, which is 90 newtons. So or plus 90 newtons has to be equal to whatever's going on down in this direction. This one here, which we got to be 490 newtons. You don't have to put your ends in, as you know, you can leave them out till the end. So the normal reaction at the ground is going to be 490 minus 90, which is 400 newtons. Part 3, the magnitude of the friction force. You know at this point for F is equal to ma. So this friction force, F is equal to ma, but F is equal to mu r first. F is equal to mu r. So we have mu, which is 1/4. So this is this magnitude of this friction force, 1/4 times r, which we got to be 400, which will give 100 newtons. And then, so that's what's going on in this direction. And we also have an arrow going in this direction opposing it. So this will give me the resultant force, which we probably need. So that's 120 minus 100, the resultant force. 120 minus 100 is my resultant force, which really is our F is equal to ma. That's going to be equal to 20 newtons. Part 4, the work done. We had work is equal to force by distance. So work is equal to the force that's pulling it. Back to this 120 by the distance that it's traveling, 2 meters, so that's in joules. So the work done here is 240 joules. And finally, the acceleration of the block, and that's back to my F is equal to ma. So my resultant force is equal to mass times acceleration. My resultant force was 20 newtons. So 20 is equal to 50A. So A would have to be equal to 2/5, which is 0.4 meters per second squared. So I'll keep these videos under 5 minutes if I can, and we will move on to the second example in the next video.